16th year, although we did miss one for COVID, so it's actually 15 times you've been here. We've been to all of them. So we're going to do, I got a cheat sheet in my pocket. So I'm not going to go as long as I did last year.
Oh, why not?
There's not as many changes.
Well,
But
wait till we start asking questions.
it's not raining. Yeah, we got to wait for the rain so you can't hear me speak because the rain stays always. Usually every year that's the way it works out. But most of the changes are with 285, 290. I think everybody knows that. Turbine is still the same as it's always been. The XEL, the XE, there's changes coming on that. That's basically the motor. This is a new motor we're making, and this guy right here, he's going to come up and talk to you a little bit more about the details on that. This motor is going to be, we're going to get rid of that 202 motor, the air-cooled carbureted motor, and this is going to be, yeah, and I know it hurts your feelings, but it's going to be same horsepower rating, 60 horsepower, 6,000 RPMs. It will be liquid cooled, so you're going to get longevity out of it. It's fuel injected, and so we got high hopes for this. So the block, we just got the block done machining last week. I think we finished it up, got the dowels and everything, so we're ready to send it out and get a line board to get the crank in it. But Daniel, he's going to give you more details on that. So that's what's going on with those two models. We're hoping by Oshkosh time frame that we'll have a chance to fire it up and maybe get a little bit of dyno time on it. But in realistically speaking, on production terms, we're probably a year out minimum on that. But that's what's coming on that front. So 285, 290. Last year when we talked about we were converting, we don't sell 285s anymore. We sell 290s because we've changed a lot of things on that. We also talked about at that time, we thought that we could come up with a B model on that 285, do a Bravo model, which we could do partial of the upgrades and get a better performing. After running through that, we've determined we cannot do that. So if you're holding off for 285 Bravo, it's not going to happen. It's just not physically possible with that locked up ECU. So if you're not familiar with the differences, the 285s, they had the Suzuki ECU that ran the engine. They're locked up. You can't get inside them. You can't change timing. You can't change fuel mapping, anything of that nature. So in order to make them work, we were using the DynoJet interrupter box for the fuel mapping. They work, however, when the motor is unloaded, it gets into a shake. And over time, it starts wearing parts out excessively. So that's not a good thing. So the idea was, okay, we ran that as far as we could. We couldn't really do any more to fix or change that. So we got a fully programmable ECU of our own. And this past summer, we did probably 20, 25 hours of heavy dyno testing with the dyno with it to create our own fuel maps, our own spark ignition timing systems. We've pretty much pinned that thing down. So we have a really nice running map and system on that. That system is ready to be used for customers. We just didn't develop and throw it out there. So we've been flying it for a while. We've actually got birds with that tune in Florida, Colorado, California, Canada, and they are all performing the same. Alabama. And it is fully adjusted. It's the same tune, so we don't have to do different tunes for different altitudes. The motor will self-adjust on its own. And that was the reason for doing all those birds in all those different areas, to make sure that it would operate on its own and make its own changes, and it's working flawlessly as we speak. So we feel that we are to the point now that we're happy. We can send it off to customers and feel that it's going to do well. So we are going to try, and I got to track Norbert down before this is over. We've been running frantically this morning to get all the parts lists together to come up with the cost of the upgrade kit. So if you have an existing 285, what is it going to cost you to get to a 290? So there's quite a few changes. It's the same engine block, same flywheel and things of that nature, but the alternator stator is different. You actually end up with a much better charging system than what you had before. The reluctor is different. The flywheel is balanced a little bit different. The air box is different. The coils are different. So there's a fair amount, and we'll provide that list for you. You can see, but it's all doable by the average builder. It's not rocket science. The reluctors are custom made. We make them here, so you would just remove your existing reluctor, send it in. We'll grind it, cut it, and send it back to you. Flywheel, you send it in. We have our own balancing machine we made here. We'll do all that balancing for you. There's been also upgrades on the radiator, on the cooling system. So the radiators currently actually have proportioners in the tanks where we force the flow through the entire radiator now. And it's just something that was missed originally when John put it together. There was never any put in. And we just kind of caught that by accident, where the hot fluid goes in one end and it could cut straight across the radiator and go right back out the other end. There was nothing forcing it through that, the radiator system. So that was something we did. And the other thing that we did was we actually do a bypass on the fuel pump. And the bypass, believe it or not, it's only a 1/4 inch line, but it's actually 25% more volume. So that's how much more coolant you actually end up with if you do the bypass.
Not the fuel pump.
Not the fuel pump, but it's on the fuel, on the cooling system.
Cooling
I said fuel pump?
Yeah.
Yeah, I probably did. But anyhow, I'm on cooling, just to be
Water
clear.
pump.
We're all cool, right? We're all cool. I'm on cooling. So those two things, because occasionally we'd have guys that would say they would run hot or whatever, but when we've modified the radiator system, and we do that in-house, so even if you want to stick with a 285, let me say this. If you want to stick with your 285 and not go with the 290, I still recommend that you do the radiator upgrade and the bypass. It's all external, it's not hard to do, but it is going to make a big difference on your cooling. So you won't be marginal on cooling or even have to worry about it on hot days. They run really cool and really well with these upgrades. So
Also the fuel modifications for the filter.
the fuel system has been modified to the point where we've removed the filter that is ahead of the fuel pumps. And the reason we did that is because you can get into a situation where you're under high fuel demand. Because it's fuel injection, you have a bypass system. So the fuel pump's just pumping everything it can pump, and the higher demand, the more fuel goes through. You can actually get into fuel shearing. And that's a scenario where the fuel gets under a vacuum, such a tight vacuum, it actually shears the oxygen molecules out of the fuel, and it creates its own air bubble. And so now you can get into a fuel locking situation. So we've done away with that filter, and we've moved to a high pressure fuel stainless steel downstream before it goes into the injection system. And there's a custom made bracket for that as well. If you look at these machines in here, you'll see what we're talking about. So that is also an upgrade that I would recommend, even if you want to stick with the 285. Now, we've never lost a bird, never had one come down because of it, but because theoretically it could happen, we want to just nip that in the bud right away. So that's it. So Norbert just handed me a piece of paper that says the 285 to 290 conversion, all pieces and parts together is about $7 grand. So now you know what I know. But now let me throw you a little bit of caveat to that. So now if you have a 285 and you got the blaze gauges, which are the colored gauges, you can still use those gauges with the 290 because it's CAN bus. We run CAN bus on those. Those gauges are CAN bus, they have capability of CAN bus. If you have the old style MGL, or they're the monochrome style, those are not. So you would have to upgrade if you want to run CAN bus. You can still run those gauges, but you have to run two systems. So if you run CAN bus, the difference being is the CAN bus, say EGT, the temperature you're seeing on that gauge is the exact same temperature that the ECU is seeing, and it's making its trims for. Where if you use the monochrome gauges, we got to run separate sensors, and it's going to tell you what the temperature of that sensor is, but you really won't know exactly what the ECU is. Not that that's a big deal, but you're running two separate systems versus seeing what the computer is seeing. So that's the difference there. Okay. And then you also have the option if you want to go with the new EFA system that Daniel has done. He's going to come up and talk about that as well. That is also CAN bus, right? So you can run that and run CAN bus as well. So it's fully capable with the ECU system. So I think everybody probably knows, but if you're new, the new ECU system is Bluetooth capabilities. So your buddy can sit there and watch all of your flight data on his phone while you're out there screwing around if you want. I mean, it's pretty cool, the stuff that it's capable of doing. And it has a total of, I'm always forgetting, was it 20 channels we have on that? I think it's somewhere around 20. There's 20 capable channels. We don't use all of them now, so if you wanted to add other things, you can actually run those things through that ECU. For instance, say you want to say, well, I want to know what my fuel pressure is all the time. You can actually put a fuel sensor in there, run it through that ECU system, and it'll come up on your dash panel. So there's several things like that you can add to it and monitor. So it has a lot of capabilities. It can do a lot more things than what we're used to seeing. So I think that on that front, I think that's about all I had to say. Unless somebody's got any questions, maybe before we move on, if anybody got any questions on 285, 290, we can handle while we're here.
The next number would be, what would it cost to bring plane to chopper down here and have it upgraded?
You know, we talked about this and we decided nobody's going to ask that question. So we just and then Chip showed up. So no, we are working on that. We don't have a hard number, right?
Correct.
Because all the wiring has to change, you know. So there's a fair amount involved there. The engine doesn't necessarily have to come off the aircraft to do it, although sometimes it's easier to pull the flywheel off and put that stuff back together. And it's not hard to get the engine off anyway, so it's not a big deal. But the wiring harnesses do all change. If you have the blaze gauges, that's great because you don't have to change those harnesses from there back. But if you've got the monochrome, then we got to, you know, go in there and change. If you want to read ECU, then we would have to go in and change all them. But if you want to stick with monochrome, we can stick with that harness. But we got to run two harnesses now to collect that data. So you're going from the old alternator was about 15 amps, and we're pushing 30 now. So you've got a lot more juice on board than what you had. And actually, with the old system, it produced 16, or I think it was 16, but you really didn't. That wasn't usable because it was a 5-phase alternator, and so the way it was rigged up was one phase would run the injection system, another phase would run a fuel pump, and so you couldn't tap into that and use it. So that alternator was only running those items. So really the only thing you had usable was about 10 amps. And so if you're the kind of guy that you want to load it down with avionics, you could get on the margin of, occasionally you'll hear guys with 285s that'll fry voltage regulators. Well, that's why they're trying them, because they've really only got about 10 amps available. They've got a 10-watt radio and a transponder and a, you know, ADSB, and they're running all this stuff, and you can get on that edge where you can overheat the new system. I don't think you ever get there. I don't think you could, and unless you put a big spotlight on the thing that's going to draw 20, 30 amps like Claire did on his turbine. It's possible, I guess. I shouldn't say it's not possible, but it'd be very hard to do. So anything else on that?
Just one estimate, maybe.
Well, I think what we will, hopefully we will do, this would be the plan, was once we finalize that, we'll publish that on the website, so everybody will know what it is. That way, if you don't want to do it yourself, then that would be the upcharge for doing it. So, but we don't have a number on that right now, to answer your question. So, airframe wise, there's only been some subtle changes. Basically, the vertical wing and the horizontal wing I have up here. So, the vertical wing and horizontal wings, we had tooling made, and we had a company out of Detroit, I believe it was, right, Robert?
Yeah.
Detroit, that was making them. And they were a cord wing. It was a patented process they used. Is the reason why we picked them, because for the weight and all. It was all epoxy. It was basically styrofoam beads that were mixed in an epoxy slurry, and that was the coring on the inside, and that's what made it structurally sound and everything else.
Down at your feet.
However, yeah, this is what they look like on the inside. Okay, so that company has either gone belly up or whatever. They don't answer the phone anymore. They got our tooling, they got everything, and all of a sudden we need wings. We can't get wings, so we had to make our own tooling again and create our own system. So we changed the way the coring is, and I'm going to show you why I'm really glad we did. So the coring always works well. It always has worked well, but if you have a mishap with your machine and you have the old style with the coring in it, if that blade gets hit, takes a substantial hit, and it doesn't fracture the outside, most guys are going to assume, well, it's fine. This came off of Mike's bird.
Yeah, they're the other half's down there.
And the wing actually took a hit. It wasn't a crash. He dropped his tail boom or something.
It came off the stand.
Yeah, it came off the stand. He dropped it. And it didn't crack, so he had no reason to think that there was anything wrong with it. Well, then he shows up the other day and he takes off, and a couple of us notice that his wing is back there doing this. And we're like, holy cow, that thing looks like it's broke. So we have him land and go look at it. There's no cracks in it. But what happened is, because it had a hard hit, it actually sheared and separated the coring. So that wing was actually hanging on by just this skin layer. So it's just a matter of time. It was going to fatigue, and it's going to get sucked into the tail rotor, and I don't think I have to elaborate on what's going to go on then, right? So the good news is we don't use these anymore.
Yay!
Because we developed
But
our...
you don't.
Yeah. And again, I got to say, if you have one of the old ones, don't freak out. It's fine. But if there is a mishap, if somebody walks into that thing and hits it hard, really do a good inspection on it, because that's what could happen.
How would you know if there was no crack?
Well, you can grab the wing and you move it,
Oh,
and it
okay.
should be solid.
And you
If
can
you
listen.
see this inner skin buckling, and you can also hear it,
Oh, okay.
if it's separated.
Yeah, tap tested all the way down, and it
Yeah.
sounds hollow.
Oh, okay.
So this thing actually sheared along the side and actually went through the coring as well. So, you know,
And it could be from damage, like when you're loading it on a trailer or
Oh,
something, or
yeah.
it falls over in the back, and you go, oh, okay. got
yeah,
it.
if it takes any kind of a major hit, then do the due diligence to really look at it really well. And you tapping on it's probably the first thing, like Mike says, and do the whole thing. Go up both sides, up and down it. And if it's sheared or separated, you're going to hear a hollow thud versus the ringy, sound. So the new ones, which we already started doing, we don't core them. So, and they have been through all the testing, the torsional testing, everything else. They're very strong. You're welcome to come up. These two here are done. Give them a twist, feel for yourself. But the way they're done is, I don't know if you can see that or not, but they have an inner webbing in them.
Oh, yeah.
Training
So-
day post.
Basically,
Don't
it's
move.
kind of like a spar and ribs.
Freeze.
And it's a hollow fiberglass. It's all fiberglass.
Okay.
And they are methaculated together, just like your entire airframe is. And methaculate has a shear strength of 3,500 psi, which is going to be way higher than this, right? That's the same thing the entire airframe is bonded together with. So it's now that. So if you were to get a new one, or you have a new machine coming, this is what you're going to get, right? It actually comes out a few ounces lighter than this. So there's a plus side to that as well. Because every bit of weight you put on the tail, you have to counter in the front somehow with a sash weight or something like that. So that is the only new thing as far as airframe components go on the bird. And everything coming out of here from now on will be that way. If you find one that you're questionable and you're not sure, you can always take it off and send it down and we'll check it. But if you know it's bad and you reorder one, that's what you're going to get. You're not going to get these anymore. So even if they somehow come back to life, I don't think we're going to buy from them, because now we know it's a much safer scenario than what we have. So I just wanted to brush on the new blades. Everybody's always asking about the blades, but over the course of the past year, I would always say, I think we've mastered it. We've slayed that dragon. Then something would happen. I'm like, oh my God, yeah. And it's happened like 5 or 6 times. But this time, I truly believe we have slayed the dragon. But we have made multiple blades, and they all come out the exact same every time. So I'm not going to go through all the woes, but when it comes to aluminum construction in the bonded, aluminum, nothing wants to stick to aluminum. It's just the nature of the material. So in order to get anything, even paint doesn't want to stick. I don't know if you may have in your past tried to spray paint a piece of aluminum, looks really great, and you look at it 6 months later, it's always flaking and coming, because nothing wants to stick to it. So you actually have to treat the aluminum, you have to etch it, acid it, do several processes to it in order to get something to stick. Not only do you do those processes, but if you do those processes and the timing is not right, it's like you didn't do them at all either, it turns out. So we have been in a huge learning curve, but we have pretty much pinned that down where we can repeatedly do that thing over and over again. And I'll give you, I mean, we probably did way more than we needed to do, but because of where we use it, we want to be more sure. I think if you were here last year, you seen we had an outside engineer come in and do testing on, structural testing on the blade, make sure it's in, and we're way over where we need to be. But the manufacturing process is what we've been trying to pin down now. So Wade, back there holding onto the pole, he's the blade guy. So if your blade comes apart, you call Wade. Don't call me. No, he's a great, I call him a kid. Anybody's a day old or younger than me is a kid. So, but he's very smart, very capable. He's got a really good handle on the CNC machine and all the whole process. But once we finally figured out the process, we are bang on every time. So to give you, if you don't know, we build the blades at 115 inches. The blades on the helicopter are only 110 inches. So there's a 5-inch chunk that gets lobbed off, and we did that on purpose because we take that 5-inch chunk, we cut 2 test coupons out of that. They're all the same size on every blade. And then Matthew put together a strain gauge for us on our hydraulic press back here where we can actually pull and destroy that glue joint, rip it apart, and see how much stress it takes to pull it apart. And we have 2 coupon tests on every single blade. So once the blade's made, before it's ever cleaned up, serial numbered, or anything, it gets that done first. And there's a no-go and a go gauge. So to give you, for instance, of where we are right now, where's Matthew at? I'm pretty sure I'm right about this. I'm going to be within a few pounds. Wade, you might remember this. I think the glue manufacturer says that the pull on the glue should be 82 pounds?
40 pounds per inch.
40 pounds per inch, right. So our pull tabs right now,
40 pounds
per square inch. Right now our pull tabs, which are pretty close to a cubic inch that we're pulling on, we're running anywhere from 115 to 120 pounds. So you can see we're 3 times plus over what the manufacturer even says it's capable of doing. So we're really happy with that. So that's where all of them are running right now. I don't think we've made one in several months, since we figured it out, that's dropped below, what, 110?
They've all been about like 110 pounds.
110 plus. So we would consider all those blades good blades.
Where Ernie's were a consistent 55, right?
50, well, we had some that went as high as 80.
30 to 55.
Yeah, but Ernie's was very inconsistent, and the reason we believe that's the case is Ernie didn't have a computerized oven system. So his was pretty rudimentary. He would put the glue in, throw it in the oven, and turn the egg timer on and wait to see what happened. And he also didn't have a way of testing them, which is pretty incredible when you think about how many blades he made and never had any come apart. I mean, it says something, you know, about his skill. But we are so much higher than, you know, the destructive part of it is so much higher than what he had. Now, the new blades, I mean, the more I fly them, the more I hate getting in a bird that's got Ernie's blades in it because they just fly so different. I think Dave would attest to this. It's a better blade. And, you know, I hate to be the one saying that because, you know, you're speaking to the choir here because we made it and designed it, but it really does fly better. The collective pressure on it is damn near neutral. My only concern with it right now is we have not flown a set on a 202 yet. And because that bird is so light, we may end up with a scenario where we have a negative pressure on the collective. But we can fix that with a trim tab or something of that nature. So it's not a death nail, but it actually makes it's easier on the helicopter because it's less stress on all the controls. Everything's neutral weight. There's nothing in there under bind all the time. Like the old blades, everything's under bind all the time. So things last longer. It's, you know, not going to vibrate as much, so on and so forth. So that's pretty much the latest on the blades. The tip weight is still about 1.6 pounds. The doubler is still the same. And the process as far as building it, that's all the same. So it was just the treatment part, the timing part, those are the things that have changed over time where we finally believe we've mastered it. So is there anything else that you can think of, Wade, on the blade that's pretty much it, right? So, and you?
7,000.
Yeah, last year when we were experimenting with running the 290 up to, that's an 8,500 RPM engine. So we were experimenting with running it up to 7,000. This is before we did all the dyno testing, by the way. So we had noticed that the motor could get out, we could get it out of its, unloaded scenario where it started shaking at higher RPM. So we thought, well, gee, we could bump it, run it up to 7,000 RPM. We're still nowhere near the limit, and it would run smoother. But it came with a problem because the primary drive is a cog belt. And at 7,000 RPMs, as a cog belt works, as it goes around, each time one of those teeth engage that sprocket, there's a collision there. So there's friction there, which means there's heat there. And the belt has a limit on operating temperature that the manufacturer wants it to be at. 6,000, you're well below. 7,000, we're right on the maximum temperature. So we thought, that's going to be a no-go. So that's when we went into the long dyno thing we went into and just solved it at 6. So we're still back at 6. We're not going to 7 because of that one reason. Otherwise 7 would work fine. But so that's not going to happen. But now we've got the 6 fixed, so we don't care anyway. So if you see something about that, it comes up. That's the poop on that.
Also the mass airflow.
The mass airflow sensor is a new thing on it, but that is also what allows the engine. We use that for the engine to do its in-flight tuning, and that has made quite a big difference on it. The air box you'll notice it is different as well. Yeah, he's got a picture of it there. So you remember originally the 285s had the 2 air cleaners, and we went with a different air box. But then when we went with the airflow mass sensor, we had to find out a way to get it in there. So we had to make a whole new set of tooling for that. And that's working out really, really well on that. So, and it's better for weather, flying in weather. Most of those upgrades were done because of the UAVs. Those guys are going to fly through weather. Most man guys, if it's raining or snowing heavy, you're usually going to land. But these guys are flying through it. So we needed to protect the induction system and all that. So I would, if you have ideas of changing the shape of any of that stuff, I would caution you, because if you change that stuff, it changes the way the motor runs. The 2 strokes, it's all about airflow. And if you change sizes and shapes and add turns and stuff to exhaust or intake, you've changed everything. So if you use what we send you, it's going to work fine because we've done all that work already. But if you think you're going to change it, I'm not saying you can't, it's your helicopter, you can do anything you want with it. But just be aware, you might fire it up and you might not have enough power to get off the ground because you've just changed airflow on it. So everything else has to change. And it's a long process. Unless you got a dyno in your backyard and you want to go through all the crap we did and spend tens of thousands of dollars, have at it.
Muffler.
And just allow us to steal your ideas when you're done.
Sure. Muffler development.
So, yeah, so then the exhaust systems on the 290 is new. By looking at it, you probably can't tell a whole lot of difference, but it is new. The old manufacturer, and I don't know what it is about these old guys, they just want to retire. And so all of a sudden we can't get stuff, and so we explored the idea of doing our own, and we're still kind of talking, kicking it around, but this fellow in the blue shirt right back here, I'm going to embarrass him. He works for the company that was brave enough to tackle developing new exhaust system for us. Basically, we're going to take our old system, because it worked fine, duplicate that system, and they've actually improved it. I think so anyways, and I think everybody that, we have one on the Blackbird out here, that's the prototype. When we've done several, flights with it and whatnot, and it runs just as well with the original tuning and everything, but it's got a different sound to it. It's actually a deeper, throatier sound, less tinny, pitchy sound. And everybody that's watched it fly and heard it fly says, yeah, that definitely sounds better. So I think there's an improvement. Now, why it sounds better, we haven't figured that part out, but the good thing is it sounds better and it runs just as good as the other one did, right? So in the future, because we have so many guys waiting on the exhaust to finish, I think we got 7 birds sitting in that building over there. They just need a muffler or they could go, So these guys are frantically, and now that we got the prototype done, it works. They're frantically trying to get us caught back up. So for short term, we're still building that way. long term, we're looking at the possibilities with them and some of the people they know, experts on their systems, doing a hydroformed, possibly exhaust system where there would be no welded seams or anything. It's much smoother, it's cleaner. You know, they got some really sexy looking stuff they do nowadays too with that stuff. But it would be easier for manufacturing process, it would be much quicker. And I think you actually probably get a better system because every one of those weld joints is a ridge for airflow to trip up on, right? Where if it's hydroformed and there's a constant taper, it's much smoother and things of that nature. That's something that may be coming in the future, but that's not going to happen for a year plus. But that's what we're looking at to do there in the future. And so I think that's all I had for everybody. So you going to go first, Daniel? Or was it Matthew?
Hit the next slide and we'll see.
Who's up?
Well, I gotta come out of it.
To Daniel?
Well, we'll open the presentation.
Yeah. So Daniel, if you haven't been introduced, Daniel and Matthew are actually brothers and they're twins. I know they don't look like it, but they are. And obviously Matthew eats most of supper. But very smart guys. Very good. They both are graduates of the college here in Gainesville. Very talented, very smart. Daniel has done all the modeling on the new engine. And so he knows all the specifics on it, so he's going to go over that. And then Matthew's going to come in and talk about the electronic stuff.
Matthew's gonna go first because that's his slide.
first on
Oh, Matthew? Okay. Reverse that then.
You're talking with the two, though, right? You're talking about here.
Yeah.
Well, and the other thing they're going to talk about is the 2.0 that the upgrades we're going to do on the electric bird, that we're doing some changes on that as well.
Before you get started, turn that mic that way, you get the ringing.
Yeah. Is it next slide? Have the next slide, Mike.
Oh, now you want.
This is a commercial break.
Hey all. So basically, I'm just going to do a quick overview of the specifications of the electric bird before we talk about some of the changes that we're making to it. So I think you guys have all seen it out there, but it's got an MRAX motor on it. It's a company out of Slovenia. It's a 29-pound motor. It's rated for about 100 horsepower continuous, 165 horsepower peak. We're not using that much. We're using about 60 horsepower to get it off the ground. And the whole bird's about 460 pounds. Our motor controller, it's made by Borg Warner. It's that big old box you see sitting underneath the motor. That is also bigger than the motor itself. That thing will do 100 kilowatt continuous, and it's in charge of the speed control for the motor because it's totally speed governed. There's no throttle or anything on it, and it also talks to our battery management system to make sure that it's not drawing too much from the batteries. So for our cell pack, it's an 80 cell pack, LG Chem cells out of a automotive application in there. About 183 pound pack. It's 336 volts, fully charged. About 45 amp hours, so that's 15 kilowatt hour. They'll put out 400 amps continuous, 800 peak. So that gives us about 25 minutes of hovering time, and unknown for what it's going to be in forward flight, but we're expecting it to be around 35 minutes, and we'll see. Daniel's going to talk about why we haven't done that yet. And in terms of the charging it, if you had a good enough charger, you could charge it from 0% about half an hour, charging at about 70 amps is what it can charge at. And our battery management system, it's a little box you see sitting to the right of the seat that just measures the temperature of the cells, and it uses those temperatures as well as a current sensor to make sure that it's we're not overheating the battery pack, and we're keeping all the cell voltages somewhat close, which is important for safety and longevity of the pack. So yeah, so that's pretty much an overview of it. Daniel's going to talk about a couple of the changes that we're making to it to make sure we can actually realize that 25 minutes in flight. And you want me to talk about why we're doing it? So basically right now, we're running that motor 1-to-1 with the tail. So we're running it at 2750 RPM. And the issue with that is that basically it's too much torque for that motor. So the as you know, the horsepower is related to the torque and the speed. So currently at 1-to-1, the motor, it gets hot, it doesn't overheat, but mainly it's actually the motor controller. In about 5 minutes, because the motor controller is air cooled, it will start to cut back. And one of the ways we can change that is by increasing the speed of the motor. So when we do that, it's going to be the same amount of power at the shaft, but it's going to be less torque, so less amps. So that's going to keep the motor controller a lot happier and be actually in a range that it's continuously rated for. And that's going to require us to do some changes with all the mounting and stuff, and putting basically a sprocket reduction on that. And Daniel's going to talk about that a bit and some of the modeling for that, where we're at with that.
Sure. So on the 2.0 XEV, we are doing a 1.8 to 1 speed reduction from the motor to the output shaft. So that's using a 30-tooth driven sprocket and a 54-tooth drive sprocket. We had to kind of move some stuff around in the mounting at the rear of the helicopter, so that the motor controller is now going to be sitting underneath the frame that holds the motor and the reduction assembly. The reduction assembly is similar to what's on the XCs. There's a couple of things that are repositioned, made a little larger, made a little smaller. And then new framing to accommodate all those changes. But that's going to start manufacturing like this week, so we're excited for that. So now I'm going to give you a quick overview on the gasoline motor that we've been developing. I did kind of a higher level talk about it last fly-in, so I'm just going to kind of glance through some of those same slides and then give you an update. So why are we making this engine? I'm sure that you guys that fly these know that the MZ202 engine has some issues, and it leads to a fairly low time before overhaul. The manufacturing also got moved over to China on those, and you can have your hesitancies about that. And then we still like having that model below the 290 and the XCT, so if those engines are iffy and we want to have that model, we need an engine that meets that need. We also like to bring some components in-house because it's just good to have kind of control of your own supply chain. We're good for the next one, Mike. So our requirements for this engine were to at least match the power and the torque of the MZ202, but not really exceed the power of the 290. We'd like to run it on 91 octane or 93 octane pump gas with a lower fuel burn rate than the 290. The weight of the whole powertrain isn't going to exceed the weight of the 202, and our stator capacity is going to be 200 watts to 250 watts at 12 volts, so roughly 20 amps. So just an overview of kind of the general systems relating to the engine. It's going to be liquid cooled. We're going to be using a PWM controlled water pump. That means a electrically driven water pump. We like this because we can operate it independently of engine RPM. If you need lots of cooling capacity, you know, run the thing at full tilt. If you don't, then don't. It's also easier to package. We don't have to accommodate for it on our actual block design. We can put it where it needs to be on the engine. It's going to be fuel injected with two 38mm throttle bodies. We like fuel injection because you can get cleaner combustion and you don't have to be an expert on carburetor tuning to get your bird up in the air. Tuning is near infinite. We can do open loop or closed loop, and it's going to work with our existing Max CCU systems. It's going to be electrically started, as all of our other engines are. It's a Bendix type starter with a ring gear placed onto the flywheel, heat shrunk on. Cylinders are a unitized casting, 72mm bore. The reeds are on the cylinders, and it's liquid cooled throughout the whole cylinder block. The block itself is a two-piece design. The studs for it thread into the lower case, go through the top case, and then you fasten the cylinders onto those. There are blow-through oil ports for the main bearings. So instead of relying on your main bearings to be splash lubricated or kind of just seeing the air-fuel mixture go by them, we're actually forcing a little bit of that mixture through them, so that should reduce wear on those. The main bearings are going to be retained by a steel ring, so your crank can't walk, and the oil seals are going to be captured on either end by plates, so you don't have to worry about seals blowing out. Crankshaft is fairly typical, multi-web design that just presses together, that's pretty common in power sports. The center labyrinth is aluminum, and it is fully rebuildable. Some renders of the prototype assembly there. You see the actual parts up here on the bench. And the project status, we are getting ready to line bore the block and do some final machining on the ends of it. And then we're going to be sending one of our crankshaft webs out to be hardened and have a hole poked in it. And then we can press that together with the rest of our crankshaft. I'm hoping in 2 months we're going to be burning gas on this. So.
All right, so I'll keep this pretty quick because most of it's just a rehash of what I said the last fly-in. But we are currently designing a EFIS platform for any of our mosquitoes. And so I guess I'll go over some quick specs. You may have already seen it in the black test bed out there, but it's got an 8-inch sunlight readable touchscreen that's totally waterproof. Internal to that, our little box, we have right here. Here's the actual box that sits underneath the seat. The thing that's up there on the dash is just the monitor, but it's got a 9 degrees of freedom inertial measurement unit in it, and barometer built into it for altimeters. And currently it talks entirely over the CAN bus to the Max ECU. It can also talk to the MGL RDAC, so this would work for the turbines and the 202 models. Just a quick overview of all the gauges provided, but generally, if the ECU is reading it, you can display it. I've set it up so that it's totally configurable on what gauges you want, and as you build the your helicopter and spec, if you want fuel pressure and all that, I can actually go ahead and set up the screens for you guys while you're doing that. So it's very, very customizable. I'm going to skip over these, but this is kind of just, it's gone through a lot of changes. The Virtual Horizon is a lot smaller there. In some pages it's actually gone entirely. But this is just kind of to give you an idea of like what the gauges are going to be looking like. For example, I've actually combined the rotor and the engine RPM gauges together, kind of like a helicopter style, so that you don't have to look at two gauges at the same time. But it's fully configurable. You can see all your EGTs, your gearbox temperatures, RPM percentage, or raw values. You have airspeed, altimeter, the Virtual Horizon if you want it. Found out later that most people don't need that, which makes sense, but just a nice thing to have, I thought. But yeah, so basically when you order one, we can go through and we can set it up to look just how you like. Any gauges you want, you can put on there. Totally customizable. It could be customized by the end user, although it's generally not easy if you haven't got any experience working with like Linux systems or Qt widgets. But the point is, it is customizable. so who would want this? So in terms of like the price point, it is going to be cheaper than the 3-pack of MGL gauges, so it's going to be cheaper than $1,200, but at the same time you're getting a lot more functionality for that, and it's going to be tailored just to your bird as well, so it is nice in that regard. Things that why you might not want it, so there's not going to be any maps, no ADS-B support built in, transponder radio, any of that stuff. You want to go for a full MGL setup then, but this comes in at around $1,000 as opposed to like $7,000 for the whole MGL setup there. So
Plus we make it here.
right, plus we make it here and it's customized for you. I don't have any demos here right now, but we could look at it on the Blackbird later if anyone's interested in that. So I can show you it actually working and stuff. I think that's all I had to say about it. So yeah. Dwight gonna come back up, or is that it? Is Dwight still here? Am I away? Just gonna close it up. Well,